All right. So yeah, so the talk what I'm going to talk about is Mochi. So Mochi is a project that we've been collaborating with Argonne, Carnegie Mellon, and Los Alamos with, and we've been working with them for quite some time, since 2014 or 15, and creating data services. So for HPC, though a lot of the things that I'm going to talk about today are also very similar to cloud. So if you're not an HPC person, a more cloud person, you'll find a lot of things probably very similar. So first of all, why do we need data services? I mean, in HPC, what is new in our approach? And that's kind of things that we'll try to to answer. How do we know we're on the right track in this project, and what challenges do we face? First of all, I think it's kind of important to kind of define the term data service, and in that context, data service is either a component or a set of components that provide a feature or set of features to the user in response to an application need, and may have different definitions, but that's the one that we try to stick with here. Kind of define two different terms. There are monolithic data services versus microservices. So by monolithic data service, we mean things like kind of very big software packages, like, for example, an entire file system package that you interact with, versus microservices that just provide a very small functionality. So I think one thing to consider is that there's been a lot of evolution in terms of HPC workflows, and the traditional HPC workflow that everybody kind of has been used to is that you have your simulation code, you interact with the storage, and then so you write to the storage, and then you read back from it, and you either visualize your data or do data analysis on it. That's no longer the case, and we've seen really a need for more complex workflows. You have either another simulation code that is interacting with your first simulation code, so you do code coupling. You either need for some telemetry services to kind of monitor what your simulation code is doing, or you actually doing data analysis of your simulation on the fly, or also doing like in situ visualization, where you're kind of bypassing the storage and doing visualization of your simulation. However, well, I think it's worth noting that creating a new data service is not an easy task, and I think everybody who's kind of tried to do that has been facing similar challenges. So there is communication between applications. So you need to know about networking. You don't want your components to crash just randomly, otherwise everything will crash. So you have to be resilient and support faults. Eventually, you have to do some deployments, and also eventually consider security questions. Beyond workflows, I think in the kind of traditional way of interacting with the storage system is that we've had, I mean, application and simulation codes have really follow very different models, and they all have different access needs. So for example, you may have a particular simulation that just has small writes and index queries. You may have kind of machine learning ensemble that is caching large write-once objects, or you may be doing analysis of experimental data, and in this case, you're doing bulk ingest and interactive access. So those are all different access needs. However, they've been kind of forced to use the same well, in the case of HDF5, the same native way of accessing and interacting to the parallel file system. In the case of HDF5, through the native file format, but underneath what it does is just standard POSIX system calls. So that's an issue. So one solution for that has been introduced with HDF5 is through the virtual object layer. So the virtual object layer is really kind of a portal to new data services that we can just feed to HDF5. And the nice thing with the VOL is that it's directly it can directly be adapted to the application data model. You could also do it in some sense with the virtual file layer, but the problem is that it's too tied to the native file format, and you will have restrictions, and you won't be able to deploy the same type of data service as what you would be able to do with the VOL, where the idea is really be able to have your application express its data model to the storage, and not forcing the data model to match what the storage is asking you. And so the nice thing with the VOL is that you can also easily switch from one connector to the another, and you can have this way multiple data services that you can interact with. So again, here we switch to a different kind of model where so each type of application has different access needs, and for this, that means you have potentially different data services and not a single one that must fit everything. So the data model of the application is really dictating how things should be stored, and not the opposite. And so the idea is to have kind of composable building blocks, like components and microservices, where you can do things like data staging, code coupling, telemetry analytics. So really to have specialized services that serve the application. One example, so the principles behind Mochi. So that's an example that we've kind of in-house thing that we've been working with to kind of define an object store. So this uses, so you see you have application nodes and object provider nodes. So that's basically client and server, where you have the application process that talks to the object API, and so you also have client memory. And the idea is to interact with the server here that provides some components like so there is what is called the bake client, but that's just the object store name that then stores the data using either PMDK or POSIX, and then there is a key value provider that stores using some things like LevelDB and so on. So to do these kind of things, what is the approach with Mochi? So there is, you see the, I hope you can see my mouse. The number one is the core functionality that is kind of, the idea is to develop standalone components as microservices that can be reusable in different configurations and by different teams. So you see the KV provider here. Underneath, we have all these components. We have 3 components here, one called Margo, Mercury, and Argobots that are responsible for, Mercury is responsible for the communication, RPC, and Argobots is for the user level threading. And by the way, I think you've heard Argobots in Tank's talk earlier using asynchronous IO. The second thing is that there is some modularity and easy adaptation to new memory storage, networking, and other technologies. So we can really have different hardware and kind of use the latest things. The third thing is that there may be also multiple methods of programming, C, C++, Python. So we have to kind of provide different things that are adapted to these software packages. And the fourth thing is that this Mercury package, and we need to have this portable communication library that is designed for performance across HPC environment. Where we are here is that we have a set of core components. So like I just said, Argobots, Mercury, Margo, Thallium, SSG, that all provide some core functionality. And then we have either utility libraries. So all these are different packages that we provide and that you can reuse to make your kind of custom data service that is more adapted to your application needs. I don't want to go too much into the details here. But so how do we know we're on the right track? So now the good thing is that we've had quite some success with different projects. Some of them that I'll just talk about briefly afterwards here are DEOS that I presented yesterday that reuses some of these components like the Mercury RPC package, DataSpaces, and proactive data container that I'll just talk about quickly. Yeah, so we have several projects that are using them, and they all use different components. So DEOS, so I talked about it yesterday, if you saw the presentation. So the idea is that, so if you want to create something like DEOS, you of course can either create something, do something like was done with Lustre, where you have this kind of monolithic software package, or you can take advantage of smaller components and have things more modular. And to do something like that, that's actually what they do, is that you can have define the functionality more through microservice architecture. So that's what you can see here. So for RPC, in the software, they use Mercury and the Fabric. For collective, they have their own kind of package. Persistent storage, they use PMDK and SPDK. For the thread model, they also use Argobots that they reuse. And you can also they can also define this collection of microservices for either objects, containers, pools, do the concurrency control, self-healing, and so on. So that responds to the application data access needs. DataSpaces is also a bit similar if you heard about it. So the idea here is you really want to try to have a data service that does coupling for data staging between workflow components. And so you have simulation and different applications, and you want to get the data in a staging area and get it from there. So they also use the components here, and mostly Margo and Mercury for the communication. Proactive data containers, so that's from LBNL that we worked with. And the idea here is to have a way of unifying different storage tiers of memory and have mapping and transformation between all these storage tiers that happen kind of transparently for the application. So for this, again, you can, well, either start from scratch, but that would require a lot of effort, or use some of the components that we define, where, for example, here we used Mercury for the communication, but we could also use, again, Argobots for the user level threading, and so on and so on, or also use a key value interface. So the advantage and challenges. So what does it mean to have multiple services? Well, that allows you to customize your environment, and that definitely adds value to the vendor provided capabilities. So what I mean by that is that when you have access to an HPC machine, you have usually have just the kind of based software that is provided, and using that you can have exactly what your application needs. So services can allow for reusability of functionality. So that's something that we pay a lot of attention to. Complexity of the players complicates performance tuning, however. So having different software packages, it makes it a bit more difficult maybe to tune, but it requires also additional tools. So that's what we've been working on. And one of the things also that we've seen is that gaining the trust of users and facilities is maybe one of the challenges. But the fact that we gain traction with multiple projects helps in that. In conclusion, so I think, well, we have some scientific achievements in the sense that we've kind of, Mochi has enabled a lot of projects to create rapidly without a significant development effort to create new data services. Things that took many years to develop and productize, we can now do it more efficiently. Also create, by the same occasion, new data services for HDF5. We use RDMA, user-level threading. So we've kind of defined new methodology for the design of services. And yeah, the idea is to have reusable components, and we're also kind of exploring exploring approaches to configuration on optimization. So that's what we've been working on lastly. Yeah, that's it.
Cool. Thank you, Jerome. Any questions? We have a couple of minutes. While others are warming up, can you give some more details on Bake? What protocols does it use for remote communications?
Well, Bake also uses the Mercury interface, so it just uses libfabric, and it can use InfiniBand or TCP and so on.
But does it also do remote data transfers beyond multiple?
Yeah, I mean, Bake is kind of similar to an object store. It's kind of a prototype object store, I would call it, that you can use to just store your data using kind of a key value interface also.
Okay. Okay. Any other questions for Jerome?
Yeah, actually, this is James. I had a question about the microservices, and how did you decide what level of granularity to make those services?
Yeah, that's a good question. So our approach was more from bottom to top. So we kind of really started from the low level, and then going slowly to the higher level services. And that's how I think we define kind of the granularity. So for example, we have like, so the Mercury service is really dedicated to RPC networking. Then we have user level threading. So we cannot really isolate the functionality, but then that's higher level services may encompass more things of this. So it depends also on the needs that we have also. So
okay.
Right. Cool. Thank you.